In this question, we have to find out the acceleration of the mass m3, which is upward acceleration. It means that the mass m3 m1 must be more than the mass m3. Okay, it is obvious. So that's why the acceleration in the mass m3 is up. That's a positive acceleration, and m1 has the same acceleration, means magnitude of acceleration, but it is downward. Okay, so I will explain to you this question by two methods. The first method is very easy, and in a second method, for which I will make a separate video. In that method, we will set up equations and we will simultaneously solve them. Okay, so in this question, as you see, if we say this is our system, so in our this system, we see the two strings. This is a one first string and this is a second string. Okay, in these two strings there will be the two force of tensions. So this tension, let's say T1, will be cancelled out, means like they have a same magnitude. Okay, because both masses m2 and m3 are connected with the same string. In the same manner, this tension force have a same value as this tension force T2. Okay, so it means that these tension forces are inside the system and they will cancel out each other. The force which that will not cancel each other, the force that will not be countered, is this force. See carefully that this is a force of friction. And why is that? Because this is a force applied on m2 and we know that the system, this m2, is accelerating in this direction. So that's why the frictional force must be in the opposite direction. Okay, so as you know from the Newton's, like if I show you this system, let's say this is our m1 and it's connected with m2. There's a no contribution of the pulleys in this system. We are not assuming the rotational motion of these pulleys. Okay, so basically this is our system and you can see this is a direction of the frictional force exerted on it, and that should be mu normal force. Okay, and that normal force must be equals to the weight. Okay, because you know that the normal force is equals to the weight of this. Okay, secondly, the force that is pulling it down is m3g and the force that is pulling down is m1g. So it means that what is the total sum of all forces? The sum of all forces must be equals to m1g minus m, like mu m2g minus m3g. I'm talking about the magnitude of the resultant force. So students, if you have to find out the acceleration in the system, which is same for all of them, like right now we are applying it for m3, so acceleration will be equals to, in fact it should be the total mass, so acceleration must be equals to the resultant force, the net force, divided by sum of all masses m1 plus m2 plus m3. So then it is m1g minus divided by sum of all forces. Okay, can we take g out of all of these terms? So what we will be left with, that is in the numerator, and in denominator we have m1 plus m2 plus m3. So this is an acceleration not only in m3 but the whole system have this same acceleration. That's why the right answer must be option D.